A small plane can fly 1,575 miles in 7 hours with a tailwind. On the return trip, with a headwind, the same trip takes 9 hours. Find the speed of the plane in still air and the speed of the wind. For this particular problem, how about if we let p equal the plane's speed in still air and w equal the speed of the wind? The speed of the tailwind can be found by taking distance divided by time, and we travel 1,575 miles in 7 hours. So when you divide those, you get a speed of 225 miles per hour. The speed with the headwind is going to be that same distance, 1,575 miles, divided by 9 hours, because that's how long our trip takes with a headwind. And that comes out to an actual speed of 175 miles per hour. We need to write an equation that includes our tailwind. And with a tailwind, the tailwind will push the plane's speed so that it goes faster. And so we have the plane speed plus the wind speed is going to equal our total speed of 225. Our equation with a headwind is going to be a little different because a headwind will slow the plane down. So we have the plane speed minus the wind speed when we have a headwind, and that gives you a total speed of 175 miles per hour. I notice these two equations are both in standard form, so the elimination method would work really well. In fact, if I were to just draw a line under here and add the equations, the wind speed would disappear and eliminate. So p plus p will give us 2p, and that's going to equal 225 plus 175, which is 400. If we solve this, we'll already know the speed of the plane. Divide by 2 on both sides, and the plane is going 200 miles per hour. If the plane plus the wind is 225, then that means that 200 plus 25 is 225, so the wind will have to be traveling 25 miles per hour. You can get that by plugging the 200 into either of these equations. Plugging in the top one, you subtract 200 from both sides, and the wind is 25 miles per hour. So our two speeds are 200 miles per hour for your plane and 25 miles per hour for your wind.